Good day guys, welcome to our class Calculus 2 and our topic for today is logarithmic functions. Logarithmic functions are integral of any quotient whose numerator is the differential of the denominator, which is the logarithmic of the denominator. So in front, you could see three different formulas for logarithmic functions. So the most common and most commonly used is the first one. So let's try to have some example. So here we have an example, integral of x dx over 1 minus x squared. So let me erase this one. Let me explain first. I've write it already. So in order to know that the given equation, for you to use the logarithmic function, you need to let your denominator as u, then derive that derivative of 1 is 0, derivative of x squared is negative 2x dx. In this case, we just transpose negative 2x to the other side, then you will have dx equals, transpose to 1, you have du negative 2x. After that, all of this will be substituted in your given. So actually, you could have any means you could use. Here, I'm just doing this one step by step so that you could know where did I get those values in your electronic notes or e-notes that I've given you. So you could see there how it is done. So from here, need to substitute. You have integral. You have your x here. What is our dx? Dx is du minus over negative 2x. So we have du over negative 2x. Then all over u. So if you could see here, we could cancel your x and your x in your negative 2x. Then we have du over negative 2 then over u. So we can transform this one into, diba? You have du over negative 2 times 1 over u. Transpose this one, so you have 1 over u. Or directly, you could have move all the constant. The discussion we've done in the previous topics, move the constant values outside the integral sign. So we move the negative 1/2 and put integral. Then what remains is du over u. And that gives us negative 1/2 ln of u. And remember, our u is equal to 1 minus x squared. Okay, so there we have your answer. So first look at it and try whether we have things we don't consider. Okay, so next, let's try using this formula number 2, the same given. So we have example for B. Okay, so we have the same given, x dx over 1 minus x squared. In this case, in order for this to be like this, we need to transform this one to negative x dx over x squared minus 1. if you could see, if I multiply, why it becomes like this? If I multiply negative here, it becomes negative x squared and then positive 1. So the same as in the given. So that's how, or this is what's the difference of A and B. So from here, so your U will be x squared minus 1. And your du will be 2x dx. And your dx will be du over 2x. Substitute it now here. You will have negative integral, what is over dx? Du over 2x over u. Then we could cancel this one. Then we have negative du over 2 over u, or as we've done it like before, we have negative integral of du over 2 times 1 over u. So therefore, you have moved outside the integral sign, the constant value, you have du over u. And this gives negative 1/2 ln of u. Sorry, we forgot our plus. Sorry. And ln u plus c. Then we have negative 1 over 2 ln. What is our u here? That is x squared minus 1 plus c. In this case, our x must be greater than 1. Why? Because it will be, if this is 1, so that becomes 0. So, and actually for our c, it's just the absolute value. Okay? It's just the absolute value where the application yields x dx over where's the given? 1 minus x squared. So basically it will yield an answer of negative 1 over 2 ln of absolute value of 1 minus x squared plus c. Okay? So basically, like this one, but it is in absolute value where your x must not be equal to 1 and negative 1. Why? Because if this x will be equal to 1, becomes 0. And if it is negative 1, still 0. Okay? So let's try another example. Let me get the eraser. Okay, please look at it first, and we'll have our example. So this is just telling you the difference of the 3. But actually, you could have, most commonly used is the first one man. Okay? So I will erase this one and give you another example. Okay, I'll erase this first. So while you are looking at the other problem, okay, let me erase this one. Okay, so we'll try another example, which is evaluate integral of, let's say, x squared minus x over x plus 1. Okay, so let's try to look on the given. So could we use logarithmic functions? Let's try first. If we derive this one, the derivative of x plus 1 is dx, right? So we have that one. So if you could see, the numerator is with higher degree than denominator. So second degree is the numerator and the denominator is first degree. So what we will do is by division. So do by division. Okay. So by division states you have x plus 1 divided by x squared minus x. Okay. Let's divide that one. So we could simplify it, and then it's easy for us to integrate. Okay. It's in the algebra. So here we need to look for a value that will correspond to this. So we have our x here so that we can have x times x squared, diba? When you are dividing, you need to deduct this one and your answer here, diba? You will deduct that one. So in order for us to deduct it, we need to multiply it by x so that it would be x squared. So you have x times x, you have x squared. X times 1, you have plus x. Now, in division, you will deduct, diba? You will subtract. So, x squared minus x squared is 0. Then, you have negative x minus negative x. You have negative 2x. Now, could we have another value here? Let's try. We have, in order for us to have 2x, we have negative 2 or positive 2. Let's try. If it is positive, you have 2x plus 2, right? 2 times x is 2x. 2 times 1 is 2. But you need to still deduct. Then therefore, you have negative 2x minus 2x becomes 4x. Dili siya ma-deduct. So therefore, we need to use minus. Okay? So negative 2 times x, you have negative 2x. Negative 2 times 1, you have negative 2. So you have negative 2x times negative 2x. So this becomes positive. Negative 2x plus 2x, you can cancel. Negative 2 times, negative times negative 2, you will have a result of positive 2. Therefore, you have a remainder of 2 all over this one, x plus 1. Therefore, we could say that integral of x squared minus x over x plus 1 dx is also equal to integral of x minus 2 plus 2 over x plus 1 dx. So, pariha na sila. Kini o kini pariha lang. Sir, when we will be using long division, if your numerator is higher degree than your denominator, remember, okay? You need to remember that one. So from here, it becomes much easier. This one we could integrate, this one we could integrate, and this one obviously is logarithmic function. So let's continue. Okay, we will use this one. So we will use the identity tree number 3. Identity 3. So there's separate that one, x dx minus 2 dx plus integral of 2 over x plus 1 dx. Then, as I've told you, to make it more easier, move all the constant outside the integral sign. So we'll have x dx minus 2 integral of dx plus 2 integral of dx over x. X plus 1. So from there, we'll have integral of x dx. What formula will be, what identity will be using here? This is identity number 4, the integration of powers. You have x, the power here is 1 plus 1 over the new power. Okay, here minus integral of dx, that's identity number 1. So integral of dx is x plus, now this is our logarithmic function. So our u here for this is with x plus 1. So our du is equal to dx, therefore dx is still equal to du. So therefore, you have dx over u. So we'll not yet put plus c because we're not done yet doing this one. So we will have x squared, 1 plus 1 is 2, over 2 minus 2x plus 2. Sorry, that is not dx, that is du. Okay, du is equal to your dx. Okay, so dx is equal to your du. So integral of du over u is ln u. Then they are all already integrated, so you add plus c. Okay, are we done? Not yet. Why? Because we have still u na term. So we know that u is equal to x plus 1. So therefore, we substitute it. We have x squared over 2 minus 2x plus 2 ln of x plus 1 plus c. So therefore, that will be our answer. Okay? Okay? Or, yeah, you could divide it by, multiply it by 2. Or you can have this one, so that you don't have denominator, you can multiply it by 2. So you will have 2 times x squared over 2. So wala na kay over 2. Minus 2 times 2, we have 4x plus 4 ln of x plus 1 plus c. Okay? Or you can have this one. Sakto ba? Times 2. Okay. 4, 4. Okay? So, I think we have discussed logarithmic function. For more example, so please watch the next topic, which is trigonometric functions, because we will also include logarithmic function na mga examples with the trigonometric functions. Okay? So, I think that's all. See you next session.